We're going to continue with the review for test 2. Here they give you this data. Actually, there are 29 in the sample size. And I always like to do that to make sure that when I add my accumulated frequency, it adds up to the sample size. So here, we are asked to construct a frequency distribution for the given data set using 6 classes. In the table, include the midpoints, relative frequencies, and accumulated frequencies. Which class has the greatest frequency and which has the least frequency. So the lowest data is was 30. Lowest data was 30. The highest data I have is, I think it was 539, if I'm not mistaken. So the highest data is 539. Where is my 539? Okay, somewhere in there we have 539. Okay, so that's the upper limit here. So we're going to add, we got 85 here. Oh, here is my work. So 535, it's not 539, I apologize. The highest that is 535, you subtract the smallest and then divide it by 6 because they're asking you to create 6 classes. So it's 84.2, but you always have to round up. I know that's the one we tend to forget, and usually our mistakes are in the rounding. So even though it doesn't naturally round up, you have to round it up for the purpose of creating a frequency distribution. So now the lower class is 30. When you add 85, you get 115. So if you keep adding 85, you're going to generate the other lower limits of the other classes. Then this 114 came from 115. You always subtract 1, and that is before you do a video. I mean, before you do the histogram. So this is going to be the lower limit, upper limit. So this is going to be 115. You subtract 1, and that will give you 114. You generated this 200, so is 1 less, 199. 285, 1 less, 284. 370 here, 369. 455, 454. Okay, it's always 1 less to determine the upper limit of the previous class. Now the frequency, we have the frequency. I tally them and I just summarize them here. The midpoint, you're going to add the lower limit plus the upper limit. 30 plus 114 divided by 2, that will give you 72. And that's how all the others were generated. Relative frequency is the frequency, that in this case is 4, divided by 29, which is the sample size. So each one of them, 4 over 29, 4 over 29, 6 over 29, 3 over 29, 5 over 29, 7 out of 29. So then it has 3 decimal places. The accumulated frequency, if you add them all up, it has to add up to the sample size. The class width with the greatest frequency is this one, number 7. So it's 455 to 539. The class with the least frequency is this one, class 4. It is 285 to 369. And the next one is a theory question. It's a nice break. What is an advantage of using a stem and leaf plot instead of a histogram? What is a disadvantage? So a stem and leaf plots contain original data values where histograms do not, definitely. What is a disadvantage? Histograms easily organize data of all sizes where stem and leaf plots do not. Okay. So let's see if we have another theory or if we need to pause the video. Okay, so we have another theory. In terms of displaying data, this is question 13. In terms of displaying data, how is a stem and leaf plot similar to a dot plot? So both plots can be used to identify unusual data values. Number 14, how is a Pareto chart different from a standard vertical bar graph? So the bar graph are positioned in order of decreasing from height, decreasing height with the tallest bar on the left. So it's always from the tallest to the highest, to the smallest. So the tallest bar, and then it decreases in size. So that is the Pareto chart. Okay. It's another way to organize data. Then on 15, match the plot with a possible description of the sample. So this one, if you were, the key says 10 bar 1, so that's the 101. So this one is 101, 106, 107, 108. This could represent 11, 11, 11. Then we have 11, 2, 11, 9. This is going to be 12, 0, 12, 6, 12, 8, 12, 9. So this is the key. And the best way, based on the numbers, is that it represents temperatures. Based on the values, you can say that it can represent temperatures. The first one is a top speeds in miles per hour of a sample of a sports car. Not really, because this is too low, 13 miles per hour. Grade point average of a sample of a students with finance majors. No. Waiting time in minutes in a sample for the sample of doctor's office. You hopefully don't wait that long. So it's really by elimination and thinking about which one makes sense. So it can be challenging. Number 16. So we're going to stop here and do number 16 in our next video.